Vedic Mathematics, a paper presentation in the 21st International Vedanta Congress. In ancient India, mathematics and astronomy were developed primarily to unravel the mysteries of the universe, to understand the cycle of birth and death, and to improve the quality of life through the development of technology. Rituals, such as recitals of the hymns in the praise of the Lord, Havana or offerings to the Lord through fire, and sacrifices were routinely performed. These required precise fixing of time using positions of star constellations and planets and constructing geometric shapes for Havan Kunda. Major objections of Western scholars to the ancient Indian contribution to mathematics are its lack of cold logic, consecutive arrangements, and abstract nature. Indians gave no definition, no postulates, no axioms, and no logical chain of reasoning. Vedas were transmitted orally through the guru or teacher to the disciple and father to son over several millennia before Veda Vyasa collected them and wrote them on palm birch leaves around 1000 BC. Since the disciples had to remember and transmit orally for easy memorization and recital, the mathematical foundations were presented in a highly abbreviated form as couplets, triplets, and quadruplets. Contributions of zero have been variously attributed to Hindus, Arabs, Chinese, and Babylonians. However, it is an Indian concept and can be discerned by looking at the philosophical connotations. Concept of zero was derived from the concept of void, which in turn was influenced by the Buddhist concept of nirvana, or attaining salvation by merging into the void of eternity. According to the Hindu scriptures, concept of zero implies that when all the desire of a person became shunya, that is zero, the mortal becomes immortal. Greeks, Romans, Babylonians, and many other ancient cultures proposed that the universe is composed of four elements: earth, water, air, and fire. Greeks often introduced a fifth element, quintessence. However, Indians introduced sky, or in other words space, vacuum, or shunya. Zero is called shunya in Sanskrit. Nasadaya Sukta describes in detail the state of the universe at the time of creation. Is it Big Bang? It states that there was no life or death, neither day nor night. Is there a creator? Does the creator know how the universe comes into existence, or even does he not? In a right-angled triangle ABC, AB square plus BC square equals AC square, where AC is the hypotenuse. This is known as Pythagoras' theorem and was written between 570 BC and 495 BC. But this appears in Baudhayana's Sulva Shastra, which was written in 800 BC. If p is a prime number, then 1 plus p minus 1 factorial is divisible by p. This is known as Wilson's theorem, which was written in 1770 AD. But this appears in Mahabhaskarya by Bhaskara I, who lived between 600 and 680 AD. Because of the complex nature of Sanskrit, Western and even some Indian scholars have often misunderstood, misrepresented, misinterpreted, and misattributed the Indian contributions. The five elements from which the universe is made. Prithva Paschitejo Vayu Rakasha. The earth, water, fire, air, and vacuum. Shunya. Nasadiya Sukta in Rig Veda describes the beginning state of the universe. The shloka means there was neither non-existence nor existence then. There was neither the realm of space or the sky, which is beyond. What stirred, where, in whose protection this is all a deep mystery. This shloka discusses the middle term of an arithmetic series. It means 1/2 of the number of terms minus 1 in the arithmetic series of n terms multiplied by the common difference d and added to the first term a of the series gives the middle term of the arithmetic progression, assuming odd number of terms in the series. Middle term equals 1/2 multiplied by n minus 1 multiplied by d plus a. This shloka discusses a number of terms in a geometric series. It means, given the first term a, common ratio r, and the sum of n terms of a geometric series, then multiply the sum Sn by the common ratio r diminished by 1. Divide this product by the first term a and add 1. The number of times this is divisible by r gives the total number of terms n in the series, that is, Sn multiplied by r minus 1 equals a multiplied by r to the power n minus 1. Sn multiplied by r minus 1 divided by a equals r to the power n minus 1. Sn multiplied by r minus 1 divided by a plus 1 equals r to the power n. This shloka discusses the square root of 2. It means, increase the measure by its third part and this third part by its fourth part, less the 34th part of the fourth part. If the sides, karni, of the square have unit length, then the measure of the diagonal, dvikarni, is given by square root of 2 equals 1 plus 1/3 plus 1 divided by 3 multiplied by 4 minus 1 divided by 3 multiplied by 4 multiplied by 34. That equals 1.4142158 and so on. This is accurate to the fourth decimal place. The Greeks, Romans, and Egyptians had difficulty in representing large numbers. With the introduction of the decimal system, Hindus were able to represent numbers of the order of 10 to the power 41, Adanta Singara, as they called it, in their calculations. Hindus were able to use arithmetic and geometric progressions. The following two examples will bring out the magic of geometric progression and large numbers and deep understanding of the life of the universe amongst ancient Hindus. The chess game. Once a king of Kashmir was challenged by his minister to play a game of chess. If the king won, he could behead the minister. On the other hand, if the minister won, he requested the king to grant him 1 grain of wheat with the first square of the chessboard, 2 grains of wheat in the second, and 4 in the third, so on, doubling the number of grains every time until the 64th square was reached. The king laughed at the demand and ridiculed the minister for his petty request. It appears that the minister told him that he would defeat the king twice by playing 1 game of chess. They proceeded to play the game, and the king lost. The king asked for his second defeat. The minister requested the king to grant him the wheat grains, according to his original condition. When the accountant started to calculate the total number of wheat grains to be given to the minister, it led to a geometric progression involving Sn equals 1 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 all the way up to 2 to the power 63. This ended up being 18 quintillion 446 quadrillion 744 trillion 73 billion 709,551,615 grains of wheat. This approximated to over 100 years of wheat production in the entire world. The second example deals with the problem of the end of the world. The story goes like this. Under the dome of the great temple of Benares, there rests a brass plate in which 3 diamond needles of 0.5 meters height are fixed. At the time of creation of the world, 64 discs of pure gold were placed on the needles, with the largest disc resting on the brass plate and the subsequent disc gradually getting smaller in diameter, placed on the needle till the smallest disc, that's the 64th, rested on the top of the needle. This was called the Tower of Brahma. The inscription by the side of the brass plate states that the discs should be transferred from the needle on which they are resting at the time of creation to any one of the other 2 needles according to the fixed and immutable laws, which require that only one disc be transferred at a time, and at no time a smaller disc should rest below a larger disc. The inscription goes on to state that if the 64 discs placed on one of the needles at the time of creation were transferred, according to these immutable laws, to any one of the other 2 needles, then the tower and the temple alike would crumble into dust, and with a thunderclap, the whole world would vanish. The number of correct moves required to accomplish this task according to the rules is again the same as in the previous example, that is 18 quadrillion and so on. How long does it take to transfer all the 64 discs in the Tower of Brahma from the needle on which they were placed at the time of the creation to one of the other 2 needles? Assuming that a person works the day and night without rest, making 1 move per second and without committing an error till all the discs are transferred, knowing that a year contains roughly 31,557,600 seconds, it would take slightly over 584 billion years to accomplish this job. It is interesting to compare this purely legendary and speculative prophecy regarding the fate of the universe with the predictions of modern science. According to the generally accepted theory, the Big Bang occurred some 13.7 billion years ago, and our sun is expected to last for another 6.3 billion years. Earlier, it was believed that the expansion of the universe was getting ever slower, but according to the recent theory proposed in 2011, physics Nobel laureates Perlmutter, Schmidt, and Rees, the expansion of the universe is constantly accelerating. This may lead to a big rip, leading to super low temperatures and black skies. It is difficult to predict the end of the universe using the current theories, which include big freeze, big crunch, big rip, vacuum metastability, heat death, etc. However, most of these theories would consider 584 billion years as the upper limit of the life of the universe, and hence corroborate with the Hindu predictions. A multiplied by x squared plus 1 equals y squared. This second-degree intermediate equation is known as Pell's equation. Pell lived between 1611 and 1685 AD, and is known as his only contribution in algebra, edited by Rahn in 1658 AD. This equation, with its solution, is given in Brahma Supta Siddhanta of Brahmagupta, who lived between 598 AD and 670 AD, and also in Siddhanta Shiromani of Bhaskara II, who lived between 1114 AD and 1185 AD. Trigonometric functions, irrational numbers, arithmetic and geometric series, solution of first and second degree intermediate equations, calculus, relationship among the 3 sides of a right-angled triangle, cyclical quadrilaterals, area and circumference of a circle, mensuration, surface areas and volume of spheres, cylinders, and cones, construction of geometric shapes such as using a rope, that is sulva, only are some of the contributions of Vedic mathematics covered in this paper. Indians knew that pi was an irrational number. Linderman proved that pi is a transcendental number in 1882. It appears that in a couplet in the 10th book of the Rig Veda gives the value of pi accurately to the 28th digit. Because pi is transcendental, it is not possible to construct a circle equal in area to a given square using only a compass.